Today we're going to talk about the pathogenesis of poliovirus. Poliovirus has been widely eradicated in much of the world. However, much of the developing world that have low vaccination rates and poor sanitation see more frequent outbreaks. Poliovirus is a single-stranded RNA enterovirus, meaning it invades the intestines. The virus enters the host primarily through ingestion of fecal matter from infected hosts. This can be through things such as contaminated food or water and objects such as kids' toys that are placed in the mouth. Once inside the digestive tract, the poliovirus is an obligate intracellular pathogen and reproduces in the mucosa, which are epithelial cells that line the inside of our digestive tract. Once inside, the poliovirus hijacks cell machinery, reproduces, and from this point builds until it lyses the cell. Several cellular virulence factors allow poliovirus to survive in the GI tract, and it's suggested that it crosses over into the lymphatic system. From the lymphatic system, the virus then crosses over into the bloodstream. Once in the bloodstream, poliovirus then infects motor neurons through the spinal cord, causing an immune response that attracts neutrophils and macrophages. These build inside the neuron, causing inflammation and damage. This damage can lead to muscle atrophy and paralysis, much of the signs and symptoms seen in rare cases of poliovirus. In certain cases of poliovirus, muscle atrophy in the diaphragm can become fatal, as it can cause an inability to breathe. When poliovirus causes the central nervous system and peripheral nervous system issues and muscle inflammation and muscle atrophy, this is referred to as the disease poliomyelitis. Interestingly enough, even in folks who fully recover from polio, may end up several years, decades after their initial infection with secondary disease or sequelae, in which they see new atrophy in muscle with new weakness and perhaps paralysis as well. And that concludes our overview of the pathogenesis of poliovirus.